Hello viewers. This is Kavi. So I'm an Arista certified system engineer. So in this video, we are going to be uh, learning MLAG. So I'm going to talk about MLAG. So I'm going to talk about Arista MLAG. So because different vendors have do it differently. So this particular MLAG is about Arista. So Arista, how MLAG is configured on Arista switches. So this video contains 25% theory and 75% lab. So we'll be doing I'll be explaining the use cases and the problem which MLAG solves. And then I will be doing the labs where we'll be configuring MLAG and stuff. So basically, what is MLAG? So MLAG stands for multi-chassis link aggregation protocol. So this protocol. What it does is it actually aggregates two physical switches into a single logical switch. So it's basically very similar to port channel, where we use port channel to aggregate two physical links into a single logical link. Likewise, what we are doing in MLAG. So the MLAG will aggregate two physical switch so that the connected device, for example, the host, will see a single switch instead of two physical switches. So to put it simply, MLAG makes two switches look like one switch to the connected devices. So let's see what problem does problems MLAG solves. So as you can see here, one of the problem is that dual homing. So dual homing is a concept is like where we connect a single host to two leaf switches. So this is called dual homing, as you can see in the picture. So this is what we call dual homing. This particular host is connected to two leaf switches, so which means it is dual homed. But without MLAG, let's say we don't we have not configured MLAG. Without MLAG, STP will block one of the ports, one of the links, and I can't configure port channel here. There is a rule in port channel that the both interfaces should be connected to the same switch. As you can see here, the host one has two links and both links are connected to a single leaf. So then the port channel will come up. So now there is a fundamental question: how does port channel identify that both links are from the same switch? It's very simple. It's something. So each leaf, so let's say each switch has something called a system ID. So let's say this leaf has its own system ID, this one has its own system ID, and this one has its own system ID. So this host is connected to the host has two links, and both links are connected to this particular switch, which means the host will receive the same system ID on both links. So that as host identifies that okay, Ethernet 1 and Ethernet 2 are connected to the same switch. So let me bring the port channel up. The port channel will work. Let me bring the port channel. But in this case, host is connected to, let's say, leaf 1 and 2. Host will receive one system ID, different system ID from here and different system ID from here. So host will say that, oh, no. Leaf 1, Ethernet 1 is connected to a different switch. Ethernet 2 is connected to a different switch. So I'm not going to bring the port channel up. Port channel is not possible here because it's against the rules. Okay, so we are also solving this issue with MLAG, okay, by sending the same LACP system ID. So what MLAG does is, so when we configure leaf 1 and 2 in MLAG, both guys will send the same system ID. So that host will say that, okay, I'm getting the same system ID from this link and this link, so I'm connected to the same switch. So let me bring the port channel up. So that's how it works. So let me go to the next slide. So next slide. So why is MLAG needed? As I said earlier, without MLAG, STP will come in. So in those days, STP was a primary defense against L2 loops. So STP was used to prevent loops in layer 2 networks. So what happens? But there was one pain point in STP. So STP blocks some of the links to avoid loops, because that is the primary functionality of STP. STP's functionality is to prevent loops by shutting down certain ports or interfaces. So it's doing its job. But what the primary concern for the users, the customers, is that they have invested a lot into networking, cables, transceivers, a lot. But they are not able to utilize 100% of the investment because of STP it blocked certain interfaces, so they're not able to. So because of STP, their their investment, they're not able to utilize 100% of their investment. So, and also failure scenarios. When it comes to failure, let me show here. So let me show the failure scenario here. So now let's say now we have this scenario here. So let's say this interface goes down. Now host one has to bring up this interface. But with STP, so right now this interface is in an error disabled state. Then it has to transition to a listening state, then forwarding state. So we have a considerable amount of downtime here. When one link goes down, the other link comes up, but it's not immediately. But when it comes to the port channel, if this link goes down, the other link will, continue to forward the traffic. It's the failover is seamless. If one link goes down, the other link will, because both are active. But in this case, it's active standby. But in this case, it's active. So that's what we are trying to leverage here. So what we are doing is we are trying to eliminate STP. So STP is still, we're still using STP. But what we are doing is we are trying to make MLAG as a primary and STP as a backup mechanism, loop preventing mechanism. So what MLAG does is it makes two switches act as a single switch, which means we are using active. And high availability, as I said, one link goes down, the other link will come up. We're utilizing the full bandwidth because none of the ports are blocked and all the links are active. And STP is completely eliminated. Now let's look at the scenario with without MLAG and with MLAG. So with that, so we have a scenario here. We have a with spine. So this is actually my lab environment. What you're seeing right now is this is the lab environment which we are going to work in a few minutes. So we have a spine. We have which is a layer 3 spine, and we have two leaf switches, leaf 1 and 2, which are L2, and we have a host. So without MLAG, what happens? STP blocks certain ports. As you can see here, it blocked some ports. But with MLAG, what happened? We are not blocking anything. We're just using lag, port channel on host and the port channel on spine. So we are not blocking anything. So all are active. These are active. And also the failure is if this link goes down, this link will immediately take over because it's already active. And even if this link goes down, we have redundancy. But in this case, if this link goes down, this link has to come up, but it's not immediate because of STP's transition from listening, then forwarding. It's like 15 seconds, something downtime. So what we're doing is now, and it's not active. Without MLAG, we're only using 50% of the bandwidth. Next, let me go to the next one. Next slide. So we can also use MLAG on spines as well as not only on leaf switches. We can also configure MLAG on spines where we can leverage a protocol called virtual ARP. It's also called a WARP. So we can leverage WARP, so which gives us layer 3, active gateway. So we can also do that. So MLAG for spines is primarily used on L2LS. So L2LS stands for layer 2 leaf spine. So MLAG on spines is mostly used on L2LS, which is mostly used in campus networks. So we can see a lot, MLAG, spine MLAGs on layer 2, leaf spine, because the gateway is on the spine or on the firewall. So we can see a lot of this MLAG design on spine in campus networks. And the benefits of MLAG, so as we discussed earlier, it's active forwarding. We're not blocking anything. And the fast convergence, if one link goes down, the other link takes over. Even if one switch goes down, the other switch takes over. So we have redundancy on the link level as well as on switch level. If one link goes down, we have the link. If one switch goes down, we have the other switch. For example, if one link goes down, for example, if this link goes down, this link will take over. If this switch goes down, this switch will take over. So we have redundancy across the network. So that's why MLAG is much more reliable than STP. And we are utilizing full bandwidth. And some of equivalent, so Arista call it MLAG, but there are similar technologies. Basically, it's the concept is the same, the use cases are the same, but different vendors calls it differently. Cisco call it VPC, Juniper calls it, MCLAG. Aruba calls it VSX. Dell calls it VLT, and Nokia calls it MCLAG. So just different names, but the same use case. And this is a typical active redundancy. MLAG topology. We have leaf 1 and 2, and the host is connected. Okay, now let's go to the topology and we'll look at it. So the topology is this same topology. This is the same exact topology of my lab. So my lab is a container lab. I'm using a container lab. So I will show you the lab YAML. Where is it? Okay. So I have nodes. We have leaf 1, leaf 2, spine, and host 1, and these are the links. So the switches are currently running 4.33.4m. So currently, right now, Arista has released 4.35. So we are actually 2 versions below. But still, Arista they don't recommend 4.35. They always recommend M series, n-1. That's what they recommend. So pretty much we are using the active right now. This is an active version, which is actively supported by Arista TAC. So now, let me show you the links show IP interface brief. Okay, show IP interface brief. Sorry, show interface status. I'm going to just do it. Show interface status, Ethernet 1, 2, 3, 4. Show interface status 1, 2, 3, 4. So 1 is connected to host, 2 is connected to spine, 3 and 4 I'm lag here. On the leaf 1 also. Ethernet 1 is connected to the host, Ethernet 2 is connected to the spine, and Ethernet 3 is actually connected to the other leaf. This is the Ethernet 3 and 4 are MLAG pair links. Okay, let me now go to the spine. Show interface status. Ethernet 1 is connected to leaf 1. Ethernet 2 is connected to leaf 2. Show interface status. Okay. On the host, Ethernet 1 is connected to leaf 1 and Ethernet 2 is connected to leaf 2 on the host. So let me show you the spanning tree. So let's see the spanning tree on the host. So host is actually blocking Ethernet 2. Ethernet 2 is blocking. So exactly like here, Ethernet 2 host, Ethernet 2 is actually blocking. This is the Ethernet 2. It's currently blocked because STP blocks it to prevent loops. And on the spine, as you can see here, the spine is a root bridge. Spine is the root, and that is both interfaces are in forwarding. Let's go to the leaf. I want to show spanning tree. So leaf, you're not blocking anything on leaf. Leaf 1, let me see spanning tree. It's because the root is Ethernet 2, which is connected to the spine. Ethernet 2, the root, which is connected to the spine. And Ethernet 3 and 4 are blocking. As exactly here. Ethernet 3 and 4, they are blocking here. Exactly. It's blocking because of STP. Okay. Now, what I'm going to do is, so now we have seen, so in this scenario, we have not configured MLAG yet, and STP is right now STP is the primary guardian of this network, who is actually preventing loops by blocking certain interfaces. So what I'm going to do is we're going to just replace STP with MLAG. So still STP will be in place, but STP will be like a secondary guardian and MLAG will be the primary guardian. So first, what we are going to do is, so let me explain what we are going to do in the lab. So on the spines, we'll configure the gateway on the spine and the port channel, port channel and gateway. And on the host, we'll configure a interface, a port channel. A port channel. This is going to be an L3 port channel. So we'll configure a port channel and we'll assign the port channel to the interfaces, and we'll assign an IP address to the port channel. That's it. There's nothing else on the host side. So we'll do most of the configuration on leaf 1 and 2. On the spines and hosts, it's just an IP address and port channel. Very straightforward. And this peer links is a port channel. We'll configure a port channel between leaf 1 and 2 because we don't want a single link. Because these MLAG peer links are very important for MLAG. If these links are down, the MLAG will split. Then we'll have a split brain in scenario where each leaf will think like that they are independent. Each leaf 1 and 2 will think that okay, the other guy is down. They will be acting independently. So we don't want that. So it's better to go with redundant links for MLAG pure configurations. So minimum the recommended minimum link is 2. So that's what we are doing here. Next, let's get to the lab. So I have to check some access list. Let me show you this. Show IP access list. So IP, these are the default IP access list on Arista EOS. So Arista EOS has certain default IP access lists. So it's a huge list. So here we have to focus on this IP access list MLAG. There it is. So this access list is a MLAG control plane access list. So as you can see here, the TTL value equals 255. So which means what I'm saying is this leaf 1 will receive MLAG control plane traffic from the directly connected switch. It will not receive the MLAG control plane traffic from any other switch which is not directly connected. So it will only receive MLAG control plane traffic from the directly connected neighbor. So which is just to avoid any attacker or somebody else connected from some other places to send MLAG control plane traffic. So here also we can see MLAG control plane ACL just to make sure that I only accept MLAG control plane traffic from the directly connected neighbor. So this is the pre-checks that we have to do. So if this entry is not there, these ACLs are not there, we have to configure it. If it is already there. So by default, it is already there in EOS. But if it is not there, we'll have to configure it. So what I'm going to do is first we have seen the topology and everything. So I'm just going to create a port channel. So this port channel is going to be this is a peer link. This port channel is a peer link peer link. So this is I'm going to say it's port channel 100. So this is going to be a trunk port. So why we are making this a trunk port? Let me explain. Why we want this this particular link to be a trunk port, trunk link. We want this link to be trunk link because this is port channel 100. Because let's say host 1 is connected to leaf 1, right? So this link goes down. Let's say this link also goes down between leaf 2 and spine. Now host will send the traffic to leaf 2. Now leaf 2 cannot send it directly to the spine because the link is down. Now we want leaf 2 to send the traffic to leaf 1 because leaf 1's connectivity to the spine is actually up. The interface is up. So we want this traffic to go here and then to the gateway. So for this, we want this trunk port to allow, we want this link to be a trunk port because we want this MLAG peer link to not only carry the traffic for MLAG, we want this peer link to also carry data traffic for other VLANs, not only for VLAN, not only for MLAG VLAN. We want this link to carry traffic for other data VLANs as well. It's very simple for redundancy, of course. So now let me go back to the lab. So now I'm going to assign this to the interface. Interface Ethernet 3 and 4. 3 and 4 are connected, are the peer links. Then channel group, I'm going to say channel group 100. I'm going to say mode active. So active is recommended because we don't want we want these guys to be actively engaging with the other guy. We want both guys to be actively engaging. If we configure active and passive, one guy will be actively initiating the conversation. The other guy will be just if it is passive, the guy will only reply. So we don't want like that. We want it to be active. We want both guys to be actively engaging. Now we're gonna do the same here. Interface port channel 100 on the switch port mode. I'm gonna say trunk and interface Ethernet 3 and 4 and then channel group 100. Active. So we want both guys to be active. So port channel is created. So interface status will show the port channel. Port channel is connected because both links are connected to the same switch. Okay, show interface status. Now port channel 100 is connected. So next, what we're going to do is we are going to create a VLAN. So this VLAN is called this is going to be an MLAG VLAN. This VLAN will be only used for MLAG. This VLAN will not be used for any other purposes. It's only for MLAG. So we have to use a VLAN ID which is not used anywhere in the network. So it has to be an unused VLAN. So I'm going to use a VLAN ID, the last VLAN ID, which is 4094, and I'm going to name it MLAG. And I'm going to create a trunk group inside the VLAN. So trunk group, I'm going to call this trunk group a peer group, MLAG peer. So this trunk group, what we're going to do is we'll assign this trunk group to the peer link, so that we want the peer link to carry. We want only the peer link to carry traffic for VLAN 4094. We don't want any other trunk port to carry traffic for VLAN 4094. It has to be the peer link only. So next interface port channel 100. So what I'm going to do is, I'm going to assign this trunk group to this port channel, because we want only the port channel 100 to carry traffic for 4094. We don't want any other trunk port to carry traffic for this VLAN. It's only for MLAG. Switch port, mode, trunk, sorry. So trunk group, and say MLAG, peer. Okay, now it's done. I'm going to do the same here as well. So VLAN 4094, and name, MLAG, and the trunk group has to be same. The trunk group has to be same. We have to configure the same trunk group name on both switches. It has to be identical. Then interface port channel 100. I'm going to say switch port, trunk group, MLAG, PR. So far, okay, the configurations are identical so far. So what I'm going to do next is, so now we have created the VLAN and trunk group, and we have assigned the trunk group to the port channel 100. Next, we are going to create an SVN. So SVI stands for Switch Virtual Interface, which is nothing but interface VLAN. So interface VLAN 4094. I'm going to assign an IP address, which is going to be 192.168.100.1, and I'm going to use the subnet /30. Okay, so we're going to do the same here. Interface VLAN 4094 and IP address 192.168.100.2, because it's diff2, and I'm going to use this subnet /30. Now let me show you. Show IP interface brief. Shows okay, interface is up. Show IP interface brief. Okay, both sides the interfaces are up. So what I'm going to I'm going to use one more command called no auto state, because we don't want this interface to go down. We want the status to be always up. So no auto state means regardless of VLAN configuration, regardless of interface configuration, this status will always show up, because if this interface goes down, my MLAG will go down. So we don't want this interface to go down in any circumstances. So no auto state, done. So now I'm going to try to ping. I'm going to try to ping the other guy. So which is 1.100.2. You see, I'm not able to ping the other guy. I'm not able to ping the other guy because, let me show you. Show spanning tree, because this guy is actually discarding port channel 100. This guy is discarding. That's why we are not able to ping the other guy. So since STP is blocking this, we are not able to form the port channel. So in order to form the MLAG, both leaps have to communicate. They should be reachable. So since STP is already blocking this link, what I'm going to do is we have to disable the spanning tree, because we want this port channel to we want this port channel to allow traffic for VLAN 4094, which is blocked by STP. We don't want STP to block this. We don't want STP to block VLAN 4094 on this. So I have just disabled spanning tree. No spanning tree, VLAN ID 4094. So I have disabled VLAN spanning tree ID for this VLAN. Now let me ping this guy. Now I'm able to ping, because now we have disabled spanning tree for this particular VLAN, which was blocking the traffic. So show spanning tree. it is actually the port channel is actually still discarding, but it is allowing VLAN 4094. Let me show you that. Show spanning tree, VLAN ID, so let's say VLAN 4094. As you can see here, spanning tree is disabled for VLAN 4094. So now we are able to communicate. Now leaf 1 and 2, the interface port channels, sorry, SVI 4094, they are able to communicate, which means now we can bring the MLAG up. So now let's get into MLAG. Now we are actually getting into MLAG configuration. Just type MLAG. Okay. I'm gonna show now. So peer link. Okay. So the peer link is port channel 100. So port channel 100 is the peer link. Okay. And my local interface is VLAN 4094. This is my local interface, which I will be using to communicate, using for the communication. So the peer link is for monitoring, because MLAG will continue to monitor this peer link 4094. MLAG will use this link for peer communication and this interface. And the peer address is 192.168.100.2. 100.2 is the other guy. Oh, sorry, there is a mistake in the IP address. 192.168. Okay. Okay, now I'm using the peer IP address. Peer address is the IP address of the other guy. So IP interface brief. Sorry, so IP interface brief. So this 100.2 is this guy. So I'm using this guy as the peer address. So now domain ID, I'm going to use my name. The domain ID has to match on both MLAG, uh, both leaf switches. The domain ID has to be identical or same. So on leaf 2, I'm just going to type MLAG. So I'm going to say local interface. So it's VLAN 4094 is the local interface, and the peer link is port channel 100, and the peer address is 192.168.100.1, and the domain ID is going to be Kavi. So the domain ID has to match. Okay. Now show active. See, you can see show active. Yes. You can see the MLAG configurations is identical, except that the peer address is different. It is 100.1, 100.2 here, and it is 100.1 here. Okay, so far so good. Let me check the show MLAG. It's yep. MLAG is up. MLAG is up. MLAG is up. As you can see here, the peer configuration is consistent. If it shows inconsistent, means there is something wrong with the configuration. And the status is showing active. So this is active. And one more important thing that we have to look at is the system ID. Look at the system ID of both switches. Look at the system ID. It is same system ID. This is the same system ID. Both switches are now using the same system ID. Let me show you. Show version will show us the MAC address. Okay. So as you can see here, let's see. Yeah. System MAC address. Look at the system MAC address. It's 86F2. Look at the system ID. 86F2. So what? Let me show you one more thing. Show MLAG detail. Okay. As you can see here, MLAG domain ID. Okay. As you can see here, there it is. Primary. So this guy is the primary guy. The peer is a secondary. So leaf 2 is secondary and leaf 1 is primary. So what they have done is, so leaf 1 and 2, they have negotiated, and and they had an election. So in that election, leaf 1 leaf 1 won the election, and he was elected as a primary. So the election is based on the system MAC address. So whoever has the lowest system MAC address or lower system MAC address will become the primary. So leaf 1 won the election and became the primary, and the system ID now leaf 2 has to use the system ID of leaf 1, because he is the winner. He is the primary. So now both switches are using the same LACP system ID, so that whatever switch that, if I connect any switch, any host to both switches, they will receive the same system ID. So basically what we discussed earlier, right? So basically what happens, this guy will send the system ID, this guy will send the system ID. The host will evaluate that, okay, both system IDs, okay, I'm receiving the same system ID from both links. So both are connected to the same switch. So I'm bringing the port channel up. So that's what is happening here. So now both guys are, they are using the same, system ID. So let me also show you the show port channel. Okay. Sorry, show spanning tree. Show spanning tree. Okay. Now look at the show spanning tree. If you look at the look at the address, priority address. Look at the address. It's the same. 6D4E, 6D4E. And look at the bridge ID. Look at the bridge ID. It's the same. It's basically the spanning tree is the same. It's very identical, except that if you look here, Ethernet 1 is designated. Ethernet 1 is designated. But here Ethernet 2 is root, and here Ethernet 2 is alternative. Before, Leaf 2 was only blocking Ethernet 3 and 4. Now Ethernet 2 is actually blocking Ethernet, Leaf 2 is actually blocking Ethernet 2. Let me show you the previous, this one. You see here, before Ethernet 2 was root. Okay. Earlier, Ethernet 2 was root. Now Ethernet 2 is alternative, because let me show you why it is happening. Right now, okay. Right now, these two physical switches are basically a single switch according to spine. So which means this interface and this interface are from the same switch. So what happens now? STP is blocking this link. Understood? Because still spine is the root. Spine is the root. We can't change that. So spine can't block it. So what happened? Leaf 2 is actually forced to block this link. So STP is still in place. STP is not eliminated completely. We have not eliminated STP yet completely from the design. STP is still playing a vital role. He's still blocking some ports here. He's still blocking some links here. We can clearly see that. Now, now MLAG configuration is done. MLAG is up and running. Okay. So MLAG is running now. Now, next we have to configure MLAG interfaces. So MLAG interfaces are nothing but these guys. These guys are MLAG interfaces. So this guy, okay, this guy, this guy, this guy, this guy. So these four interfaces are MLAG interfaces. Okay. So now we have to configure MLAG interfaces. So we have configured MLAG. Now we have to configure MLAG interfaces. So why these interfaces are MLAG interfaces? Because these interfaces are connected to the same switch, same host, same spine. So these are MLAG interfaces because they are connected to the same switch or device on the other side. Okay, now I'm gonna go here to the leaf 1. So leaf 1. So I'm gonna say interface. Now again I have to create a port channel. So it's gonna be port channel. So port channel. So this port channel is configured towards the host. So I'm gonna say it's port channel 1. Okay. Now I'm gonna say description. I'm gonna say it's for host. Okay. And okay. Now I'm gonna make this as a access port. So let's make it as an access port. Access switch port access VLAN. VLAN. I'm gonna allow VLAN 10 here. So VLAN 10, we did not create VLAN 10. So what EOS does is it automatically created VLAN 10. So this is one cool thing about an Arista EOS is that when you configure a switch port access VLAN, if the VLAN is not created, it is not already created, EOS will create the VLAN automatically. And I'm gonna assign this VLAN to, and one more thing is, since it's an MLAG interface, this port channel is the MLAG interface. Okay, so MLAG interface must have an MLAG ID. So I'm gonna configure an MLAG ID. I'm gonna say it is MLAG 1. So on leaf 2 as well, interface port channel, I'm gonna say 1, and I'm gonna say description host, and I'm gonna say switch port access VLAN 10. It will automatically create the VLAN. Then I'm gonna assign the VLAN ID. Okay, there are certain things we have to know. The port channel has to be same on both switches. Ethernet 1, so port channel 1 and port channel 1. It has to be same because now both switches are logically the same switch. Both switches are logically the same switches. It's the single switch logically, so we have to use the same port channel ID on both switches. Since because Ethernet port channel 1 is for host 1, so this is port channel 1. This is here it is port channel 1. Here it's port channel 1. So we are using the same port channel because it's connected to the same host. Now what I'm going to do is assign this port channel to the interface Ethernet. Interface Ethernet. I think Ethernet 1 is actually connected to interface. Ethernet 1 is connected to the host. Now channel group 1 mode active. I'm going to make it active. So then interface Ethernet 1. Sorry. Then channel group. Sorry. 1 mode active. So one more important thing is this MLAG ID has to match. Both side has to have the same MLAG ID. So both sides to have the same MLAG ID. We don't want to. This has to match. Port channel has to match, and MLAG ID has to match. But the MLAG ID and the port channel ID doesn't have to match. I can use port channel 1, but MLAG ID I can use a different number. But only it has to match on both switches. Okay. Now I'm going to do the same for the spine as well. Interface. So spine, I'm going to say interface port channel 12 will be. So description, I'm going to say it's for spine. This port channel is for spine. Okay. And I'm going to say this is going to be a trunk port, switch port mode. Trunk, I'm going to make this a trunk port, and I have to assign an MLAG because it's an MLAG interface. So MLAG interface, I'm going to say it's 12. I'm going to do the same here. Okay, let's just a minute. Okay, interface Ethernet. I'm going to say so Ethernet 2 is connected to spine. Okay, now channel group 12 mode active. Now here interface port channel 12, and I'm going to say description. This is for the spine. This is for the spine. I'm say the switch port mode trunk, and I'm gonna say MLAG ID. I have to say this is to match. Then interface Ethernet 2 and the channel group 12 mode active. So it's basically the same configuration. We are using the same configuration here. So Ethernet port channel 12. It's connected to the spine. It is connected to the spine trunk. MLAG ID 12, MLAG ID 12. Then Ethernet 2, same. So now let me show you the show MLAG. We should be seeing the MLAG interface. MLAG interface, we can say MLAG interface, or we can call it MLAG interface or MLAG ports. So MLAG. So here in this MLAG port section, if you look at the MLAG ports, if we look at the MLAG port section, we have two inactive. So the two inactives which we have recently configured, port channel 1 and 12. These are the MLAG ports. Because we have assigned the MLAG ID, so it's showing here. It is inactive. Because on the other side, we have not configured the port channel yet. Okay, on the host side we have not configured. So now let's go to the host. So I'm gonna just create a port channel. I'm gonna say this port channel 1. I'm gonna say IP address 192.168. I'm gonna say 10.1/24. Oh, sorry. So I have to enable. I have to say no switch port. Right now it is L2 interface. So now it has become L3. No switch port means it's not a switch port. It's a routing port now. It's a routed port now. So now IP address. So nothing. So just an IP address. That's it. So 10.1. That's it. This is the configuration. Just a minute. Okay, interface. Now we have to assign this port channel to an interface. Interface Ethernet 1, 2. Channel group 1 mode. Say active. Show IP interface brief. So the port channel is down. The port channel is down. Show interface status. Port channel. Port channel. Okay. Port channel 1. Port channel 1 configured as port channel 1. Interface is down. Okay. Okay. So why it is showing down? Because I have not enabled IP routing. I'm gonna enable IP routing. Now I'm gonna say show interface brief. Now it is showing up. So we did not enable IP routing. That's why it was showing down. If I have enabled IP routing, it's showing up. So port channel is connected to. Now what I'm gonna do is on the spine, I'm gonna create interface VLAN 4094. And sorry, my mistake. No interface VLAN 4094. So it's VLAN 10. So I'm gonna create interface VLAN 10 here. I'm gonna assign an IP address here. 192.168.10.254/24 and say we won't say it. So IP interface brief. If you look, it's showing down now. So when I give this command, no auto state, now I'm going to see the interface. Now it's showing up. So this no auto state, make sure that this interface is always up regardless of VLAN configurations. VLAN 10, I'll create the VLAN and interface port channel 12. So okay, this the port channel which is connected to leaf 1 and 2. I'm gonna say switch port, mode, trunk, and what I'm gonna do next is interface Ethernet 1 and 2 channel group. Sorry, 12. So IP interface brief. Okay, it's up. But IP routing, I have enabled. I've enabled IP routing, so interface status. Okay, now it's showing connected. Everything is fine. Now what I'm gonna do is I'm gonna go here. Now I will be seeing this active full. Will be seeing two. Yep, you're seeing active full two here, and we are seeing both MLAG ports are active now. Both MLAG ports are active now. So what happened now is now let me go to the host and I'm gonna ping this guy 192.168 dot sorry 168 dot 10 dot 254. I think so. Yes, we are able to reach the gateway. Show IP interface brief. Okay, we are able to reach VLAN 10.254, which is the spine. So now what I'm going to do is now we're gonna check the redundancy. How how fast is MLAG the we'll talk about we spoke about I spoke about failover, seamless failover. Now we'll see the seamless failover here. Let's see. So I'm gonna do a repeat ping. I'm gonna repeat ping. I'm gonna do it 100 times, and then the interval. I'm gonna interval. So I'm gonna go with the. So it's in the units of seconds. So I'm gonna go with the lowest unit. I'm gonna send a ping for every 1 second. So now I'm pinging. Okay, 192, 168, my gateway. So show interface status. What I'm gonna do is I'm gonna. So let me go through the topology here. So right now, what I'm gonna do is I'm gonna shut down this interface. I'm gonna shut down this interface. Okay. So let me shut down that interface. So interface Ethernet 2. I'm gonna shut this down. Okay, interface Ethernet 2 is shut down. So we're not seeing any drops, not a single packet drop. The pings are continuously going still. We're not seeing any single packet drop yet. So interface, I'm gonna show you that. So interface status. Okay. Now you see Ethernet 2 is actually disabled. But the pings are still going through. The pings are still going through. Next, what I'm gonna do is so right now we have shut down this interface. Next, what I'm gonna do is I'm gonna shut down this interface, this particular interface, which is connected to leaf 1. So on leaf 1, I'm gonna shut down Ethernet 1, basically, which is connected to host 1. Okay. Okay, the pings. So I'm gonna do that again. So right now, Ethernet Ethernet 2 is still disabled. Okay, now I'm gonna go to leaf 1. Okay, I'm gonna quickly show interface status. So Ethernet 1 is actually connected to the host, that's port channel 1, which is connected to the host. Let me show you. Show LLDP neighbors. As you can see, Ethernet 1 is connected to host 1. So I'm going to shut down this one. Okay. So interface Ethernet 1. So I'm going to quickly shut down and go to the other one. So I'm going to hit shutdown now. It's shut. I'm going to go here. As you can see here, not a single packet drop. Not even a single packet drop. We're not seeing a single packet drop here. It's still going through. Zero packet drop. Still going through. Still going through. So let me come here. Let me show you. What I've done is, what I did is I shut down this interface. I shut down this interface. Right now, the traffic is actually going like this to the spine, like this. It goes to leaf 2, then it goes to leaf 1, then it goes to spine. So we have now seamless failover. We're not seeing a single packet drop. So you can see here, 100 received, 0% packet loss. You're not seeing anything here. Show interface status. I can see disabled. So that's how MLAG is efficient, fast. So let me show you certain things. So show VLAN. If I show show VLAN, show VLAN, show VLAN. Just a minute. Show VLAN. Look at this. Show VLAN. Sorry. The VLANs are identical. As you can see here, the VLANs are identical. Ethernet 1, Ethernet 2, Ethernet, sorry, VLAN 1, VLAN 10, VLAN 4094 is the same, identical. Now let me show you. Show MAC address table. Look at the MAC address table. It's the same. Oh, sorry. Show MAC. The MAC address is table. Look at the MAC address table. It's the same. So Ethernet 4, 6D4E, channel, just a minute, 6D4E. Just a minute. Show interface status. Interface. Okay. Port channel 12 is actually down because of that. Okay. Here it's port channel. Okay. This is connected. This is not connected because it's shut down. And port channel 1, here it is not connected. And here it is connected. If 2. Let me undo the. Let me. Okay. No shot. And I give the no shot here. No shot here. Now give the command. Hit the command. Now it's identical. Channel 1, channel 12, and port channel 100. Port channel 100 is the peer link. Port channel 1 is the host. Port channel 12 is for spine. Port channel 100 is for the. Okay, now let's see the spanning tree. Let's see the spanning tree. Spanning tree, show spanning tree. Just a minute. Let me show spanning tree. Now you see the spanning tree is basically same. Look at the address, bridge ID. Look at the bridge ID. Both guys are using the same bridge ID. So according to host and spine, it is even for the STP host, spine and host. It's the same. Even we are tracking both port channel as well as STP. Okay, so port channel will see two links. We'll see two same system IDs from both links, and the port channel will come up, and also the STP will see this two switches as a single STP. So basically STP is still there. We have not eliminated the STP, but what we have done is we have tricked the other guys that I am the same switch, because we are sending the same system ID and bridge ID to make them think that I am the same. I am a single switch. It's very simple. Okay, who is the root? Now, root is the port channel 12, which is connected to the spine. Root designated. So we are not blocking anything here. On the leaf, we are not blocking anything. So basically, it is like a simple for according to STP. According to STP, it is a one switch. One switch connected to one switch, and this one switch is connected to one host. And these port channels are one link. So according to STP, this is the topology: spine, leaf, host, and they are connected to one link because it's port channel. One link. That's how we are doing it. I hope this video was really helpful for you. I hope you have learned something. And I will give the configurations. I'll give the MLAG configurations in the description. And in the next video, I will be talking about VRRP. If the video is already done, you might see this VR warp video link in the description as well. So right now, thanks for watching the videos. If you have any questions on MLAG, so you can mention it in the comment section. I'll be happy to answer the questions. Okay. So thanks for watching the video. Thank you so much.